Hi everyone. Welcome to another practice code along video. Just like the previous videos, this one's going to be optional. I'm not going to teach anything new in these videos. I'm just going to apply the concepts we've already learned. And as with the other videos that I've made, these code along practice videos, I'm just going to pull up problems that I'm seeing for the first time that use lists and solve them in front of you. So as I mentioned, the topic for this video is lists. Let's dive into it. So I have the mirror pulled up, Replit, pulled up. And the first thing I always do is I just print something out. Hello world, perhaps. And the reason I do this is to make sure that when I run my code, it does what I expect. This might sound a little bit silly, but it can happen pretty commonly that, let's see, just make this a little bigger so you can see more. It'll happen pretty commonly that the code that I write, maybe I'm running the wrong file or I'm in the wrong directory, and I want to catch those things before I start writing code so that I don't get tripped up when I see some error thinking that it's because of the code I wrote when I'm actually running the wrong program. So this is a good way to check. I just do print hello world and make sure that I can run my code, which I can. Now over here, I've just pulled up a random practice list problem. I just Googled list practice problems in Python, and this was the first link. And we're going to solve a couple of these together. So our first one here is write a Python program to sum all the items in a list. Now what's a little confusing to me is they say all the items. We don't know the type of items. And it's a little strange. It'd be nice, they really should specify. So let's say that they're all numbers. So we'll make this into a function later on, but before we do that, we're going to start with just a list here without any sort of function. So how do we create an empty list? Start off, an empty list is created with just an open bracket and a closed bracket. And we can see that this is an empty list. We can print out the list. And if I run this, we'll see an empty list printed to the screen. And we can also print the length of our list by using the len function. And you can give this length function any sequence, and it'll print the length of that sequence. The length 0. Now, if I want to add items to this list or create it with some items already inside, I just type them inside of the two brackets and separate them by commas. So here I've added 5 numbers, 5, 3, 2, 6, 1, and the length is 5 because I have 5 numbers. And I'll just change that so it's not too confusing. Whoops. There we go, 7, 3, 2, 6, 1. So we need to write a Python program that sums all the items in a list. So how would we add the items together in this list? Okay, well, the simplest thing I could think of is you start, I'm going to make a total variable, and total is going to be, we get the first item just like with strings, the way we index into a string, the way we get an item out of a list is also by indexing. We give index 0 to get the first item, index 1 to get the second item, index 2 to get the third item, and so on and so forth. So what we're going to do here is we're just going to add them all together like that. So numbers 1, and I'll copy and paste this to make it quicker. So 1, 2, 3, and 4. Again, the reason we go up to 4 is because we start counting from 0. So 0, 1, 2, 3, 4 is actually 5 numbers. And we can print our total. And 19. And let's just sanity check that that's correct. 7 plus 3 is 10. 2 plus 6 is 8. Plus 1 is 9. So 19 sounds about right. But let's say we wanted to add another couple numbers to this list. 4, and we'll actually add 2 4s, like that. Well, if I just run my code again, my sum is still 19 because I didn't add those additional 2 numbers. We also have to add numbers 5 and numbers 6, like that. And that works. That gives us 27, which is 8 more than 19. Okay, but what if I want to remove a couple of numbers and shorten this again down to 4 numbers? If I run our code, we'll see that I get an error. And in fact, the error that's given here says list index out of range. This is the error that Python will throw if you try to index into a list to get an item from that list that doesn't exist. So getting the 0th item from this list is fine. That's 6. Getting the first, index 1 item is fine. That's 1. Index 2 is 4. Index 3 is 4. But index 4 would be getting the 5th item in a list, and there are only 4 items here. So Python will throw an error. You can't do that. You can't try to get an item at an index that doesn't exist. And so maybe you can start seeing where I'm going with this. It gets very annoying to have to update this formula each time you change the number of items in the list. We did it just now. 15, that's the right answer. 6 plus 4, 1 plus 4, 15. But we can do better. So this is a place where a for loop would come in very handy because we can iterate over our list and then do something with each value in the list. So let's start with total equals 0. And then we want to say for each number in numbers, we're going to add that number to the total. And remember these for loops, how they work. For blah in blah, this is the variable name that you can use that will be assigned each item in this sequence. Numbers is a list, which is a type of sequence. And so each iteration of our loop will run with this variable set equal to one of the numbers in here. So first 6, then 1, then 4, then 4 again. So for num in numbers, we get total equals total plus num. And if we run this here, we get 15, just as we expected. Now I'll show you another shortcut here. Total equals total plus num. This is the same thing as doing total plus equals num. So plus equals is a kind of a special operator that lets us assign a new value to this thing on the left. So it assigns a new value to the thing on the left, which is the thing on the left plus the thing on the right. All right, so we've solved our problem to sum all the items in a list. Let's make this a function just to show how we would do that. So we would create a function by using def, so define, and some numbers. We'll name it some numbers, which is good, and it's going to take in a list. Actually, we'll just call it nums. That's a good name for the list. And now, inside of here, we can do the same thing we had. We just indent it, and the list that we're going to iterate over is the list that was passed into us. So some numbers nums. So for num in nums, total plus equals num. And finally, we're going to return the total so that whoever calls some numbers can get back the total. So we have a nice function here that will iterate through the list, and let's test it out. So we create a list of numbers and we call some numbers like this, and let's run our code. What's going to happen? Nothing printed. Why is that? Well, this function call returns the total. It doesn't print the total, it returns the total. And as a reminder, return statements tell Python what this expression, what the function call, should evaluate to. So this is an expression that evaluates to the total, but we didn't do anything with the total. We need to either assign it to a variable, whoops, and then use that variable for something, like printing, tote, and so this will work. Or we can just print this out directly, because this function call is an expression, it'll evaluate to something, and then that something will be passed into the print function as an argument. Great, we've solved the first problem. Let's go on to the second problem. Write a Python program to multiply all the items in a list. Okay, we can do that. This will actually be very similar to summing. So let's write a function now that we know how to write a function. And I'll copy this. And again, by the way, I don't like that they say items. They should be really clear about what the items are. so we can assume that they're numbers. And we'll call this multiply numbers given a list of numbers as an argument. So that's the parameter here, nums. We're going to do the exact same thing. We need to loop over the numbers for num in nums. And then we need to do with something with num here. Well, first of all, we need to have our product. We'll start out with to be 1. Now, why 1? We'll see why 1 in a second. So the reason it's 1 is because we want to multiply a number over and over. When we're adding, we start from 0. Because, 0 plus the first number gives us the first number. Then that plus the second number gives us the first plus the second. Then that total plus the third gives us the first plus second plus third, and so on and so forth. But if we were to start multiplying from 0, anything times 0 is still 0. And so if we start our product counter from 0, we won't ever get any sort of products because anything times 0. So 0 times the first thing is 0. Then that times the second thing is still 0. Then that times the third thing is still 0 because 0 always stays 0 when you're multiplying. So instead we start from 1 because we can do product equals product times num. And this way, on the first iteration of the loop, product becomes 1 times num. On the second iteration of the loop, we now get 1 times product times the old num, previous num, times the second num, and so on and so forth. So for each iteration of the loop, we're going to multiply our total product so far by num. And finally, we'll return num here. Why don't we try that? So multiply numbers. We got 4. That's kind of strange. Let's figure out what's wrong with our code. So multiply numbers. Okay, product equals 1. For num and nums, product equals product times num. Return num. Huh. I wonder what's wrong with our code. Because this should be 6 times 1. So 6 times 4 times 4. Let's try printing this out as we go. So we'll print num. Printing is always a good way to debug your code. So cool. We got 6, 1, 4, 4. That makes sense. Can you spot my bug? Look closely and see if there's anything strange. When I look at this, I see that 12, it looks correct. I start off my number as 1. 13 for num and nums. This seems reasonable. Nums is the list that we're passing in, and num is the name of the variable. We see that we're iterating over the numbers that we expect. We can see 6, 1, 4, 4. And then this product line seems to make sense. Product equals product times num. But I messed up my return statement. I'm returning num. And so the last number in my list will be the last value that's assigned to this variable num. So return num should actually be return product because that is the product. Now we get 96. And let's just verify that that's correct. So 6 times 1 times 4 times 4 gives us 96 as expected. Okay, look very closely. Can you think of any edge cases? So what is an edge case? An edge case is kind of an unusual case that breaks our code. Is there anything weird that would happen? Is there any possible input I could give that would be strange? One you might think of is, what if someone gives me a list that isn't made up of numbers? But we don't need to worry about that because the instructions say that this is made up of numbers. I'll give it away. What if I pass in an empty list? What should the product of no numbers be? Well, let's see what it does. If I make this an empty list, it returns 1. So that's kind of strange. Without multiplying anything, we just get 1. I feel like it should return 0. And so this is a nice case where, because our algorithm for this one case doesn't return the right thing, we can have a special case here at the beginning that says if the length of nums is equal to 0, we're going to return 0, right? Otherwise, we're going to keep going. Now notice I don't need to put an else. I could put all of this in an else statement, and logically this makes sense. This is what I want. But the reason I don't need that extra else and all that indentation is because if you were to enter this case right here, if the length is equal to 0, you would return, that would end the function. The function would stop. And so if this block isn't entered, then the function continues. So normally you have an if else because if the statement is true, you want to execute only this and not the rest of it. That happens anyway because a return immediately ends the function. So you don't need to put everything else in an else statement. Let's just run our code to make sure this works. Perfect. So an empty list, we get 0. Let's go on. So a lot of this is looking at other examples, how to get the largest number from a list. Let's do that one as well. So how do we get a large number from a list? You know what? Actually, I'm going to leave this one for you because I think this one comes up in the class work. I want to do a different example that I'm picking myself here. I want to show how do I write code to take in numbers from a user, add them to a list. So let's do that. How do we take in a number? So let's just do that one line first. Take in, let's say 10 numbers from a user, add them to a list. So the way we do this is to take a single number, we do num equals int input, enter a number. Okay, this is because input is the function that takes input from the user. It prints this string out and takes input from the user. And then int, so this input function returns a string. And so to get this to actually be an integer, we have to cast that string to an integer if we assume that our person is being nice and actually giving us numbers. So that would give us one number. And let's say we make a list here called numbers. It starts off as empty. And once we get the number, we want to do numbers.append num. And this is how we add an item to a list. But we need to do this 10 times. And so one way to do this would be to copy and paste your code. But as soon as you see something like this, alarm bells should go off. And you should be thinking, wow, repeating the same exact lines one after another, same block, this looks a lot like a for loop. That's exactly what we have here. So we want to loop. In this case, we know exactly how many times we want to loop. It says 10 numbers. So we can write a loop for I in range 10. And this will create a sequence. So range becomes a sequence from 0 to 9. And I, like the body will get executed for each possible value of the sequence, in the sequence. I get set to each possible value. So for I in range 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But we're not using I here because we don't care about the value of I. We just want to make sure that we execute this block 10 times. And you know what, I'll just make this 5 so it's easier to test, a little bit quicker to test. 5. So for I in range 5. And this will build up a list of numbers that we can then, let's just print at the end. So we'll print numbers. Let's run our code, enter a number. Okay, 7, 6, 9, 4, and I don't know, 0. And now you can see this creates this list with 7, 6, 9, 4, 0. But you know what's handy? We just wrote these functions, sum numbers and multiply numbers. So why don't we make this a little more fun? We'll say the numbers entered are, whoops, and then again, because we're printing a list here, we want to convert it to a string. If we're adding it together, to concatenate a string, if you want to concatenate something to a string, it has to also be a string. And now we'll say print the sum is plus stir and what stir of what? Sum numbers. Oops. So this is a function call that we will give it numbers, and we'll do the same thing for the product. The product is stir multiply numbers like this. So now I'll just expand this so you can see the full code. We take in all the numbers, we print out the list of numbers, and then we print out the sum and the product. Let's give this a try. So number 7, whoops. Hit enter 7, 4, 9, 5, 2. So the numbers entered are 7, 4, 9, 5, 2. The sum is 27. The product is 2,520. Pretty big product because the product grows pretty quickly as you multiply together numbers. Okay, let's see if there are any other problems I want to do on here. Here is a good one. Write a program to remove duplicates from a list. There's a bunch of ways to do this, but an important thing to know is that when you're working with lists, so I won't do this in a function, I'll just do this outside, and this will be the last problem I do in this video. Whenever you're modifying a list, you can't do that while you're iterating over that list. So for example, if I do something like numbers equals a list from with 12, 6, 5, 15, 14. Let's say I want to remove all the numbers that are less than 10. Just gonna be a little easier actually. Let's say we want to remove all numbers less than 10. The tempting way to do this is to iterate through the list for num in numbers. And we know how to write a conditional. If the num is less than 10, then we'd want to remove numbers.remove num. Let's print numbers after. This is tempting. This is a tempting solution. Whoops, it's still running my code from earlier here. I'm not going to take this input right now. But look at this. If num is less than 10, for some reason, it seemed to remove. What did it even remove? So 12, 6, 5, 15, 14. So it removed the 6, but not the 5. That's so strange. My code looks correct, but it's not working. So the reason this happens is because, think about it this way. Python keeps track of what number to look at. And I'll use this as a comment. So when you have for num and nums, and you can just imagine that this is a little arrow here. This V is a little arrow. So the first number it sees is a 12. Okay, that number is not too small. Okay, so the second number it sees is a 6. And then it says, okay, because notice what it does when we iterate. So we assign a particular value, okay, 12. Then we go on to the next value. So we move to the next number. Now we're looking at index 1, which is 6. Okay, and we look at the next number, index 2, which is 5. But look at what happens here. So in this loop, if numbers is less than 10, we remove the number. Okay, 12 is not less than 10, so we go to 6. Okay, 6 is less than 10, so we remove 6. And then at the end of the list, at the end of the loop, we always go to the next number. And so notice that by removing 6, 5 took 6's place. And then when we go to the next number is actually 15. So 5 effectively gets skipped over. And so whenever you have a case like this, where you need to remove some set of numbers, or change a list somehow, you always want to use a separate list. And there's two different ways you could do this. You could either create a new list that's called numbers to keep, and you could copy over the numbers that are not less than 10. So in this case, we could say, okay, we'll start this off to be empty. And if we want to keep the numbers that are greater than or equal to 10, we can just have that be our condition. So if num greater than or equal to 10, we're going to do numbers to keep.append num. And notice I'm missing a colon here. There we go. So now if I print numbers to keep, and I'll put our 6 back, then when I run this, this works correctly. Our new list has just the numbers over 10. Or what we can do, another way to solve this would be to create a list called numbers to remove. That's empty. And first we go through and pick out, we iterate over the numbers list and we don't change it. We just write down in a separate list what numbers we need to remove. So numbers to remove.append. So if the number is less than 10, we're going to add it to our list to remove it. And then we will do a second pass where we go through each number in numbers to remove, and we remove it from the original list. Numbers dot remove num, like this. And so notice how now, by splitting it into 2 steps, the first step is look at all the numbers and decide which ones I should remove. The second step is iterate through the numbers to remove and remove them from the original numbers list. This way, we're never modifying something while we're iterating through it. We split it into 2 separate steps. Step 1 is make a new list of what we should delete. And step 2 is go through the list of things to delete and delete them from the original list. So we're never modifying the list that we're iterating through. And now this original numbers list, we'll get Python 3 main.py, also is correct. So either approach works. I encourage you to think through what's happening here very slowly and maybe walk through it in our Python tutor. In fact, I might do that with you here because this is a common interview question, or a common kind of path of interview questions is, do you understand how to modify some things that are kept in a list? And a very common mistake is you try to modify these items while your code is going through the items. So we start off with a list here, 12, 6, 5, 15, 14, and we make a new list that's just empty. And in our first kind of lines 3, 4, and 5 here, we go through and we fill in this list with anything that we should delete. So we go through for every number. If it's less than 10, we add it to the list of numbers to remove. Now that we have that, we have the list of bad numbers. We can use this list to go, like we can iterate over the items in this list and remove them from the original list because we know that these are the items that need to be removed. So for num in numbers to remove, we do numbers that remove num. So we remove the 6 first and then the 5. And now we're done. We can print 12, 15, 14. Okay, the very, very last thing, I know I said that was the last thing I would cover. One more small thing I want to mention is how do you check if a list contains something? If I wanted to know, check if the numbers list contains the number 6. The way I would do that is I use the in operator, which we see in for loops, but in for loops, this is used to signify specifically looping. So for something in something is for a loop. But if you just use in on its own, you say like 6 in numbers, this is actually on its own an expression that evaluates to true or false. And it checks if this value is in this list. So you can do if 6 in numbers, print numbers contains 6. And otherwise print numbers doesn't contain 6. So if I run our code here, numbers clearly doesn't contain 6. But numbers to remove. What about numbers to remove? I'll just change it to it so it's a little easier here. Should numbers to remove contain 6? I believe so. Yes, so numbers to remove, which was our list of numbers to remove, and over here, whoops. Okay, we can't see it anymore. Numbers to remove does contain the number 6 because that was one of the numbers that was less than 10 that we added to this numbers to remove list. So this prints the true case. One small thing I notice people do all the time is if you just want to print true or false, you don't have to do if something print true, else print false. This on its own, this condition evaluates to a Boolean, to true or false. And so you can just print it on its own. You can say print 6 in numbers to remove. And this will print out either true or false, because this on its own is an expression, 6 in numbers to remove. The in here is an operator, and the operands are 6 and numbers to remove. So this returns true, whereas if I put numbers, it should return false because we should have removed all the numbers that are smaller than 10. So yes, it returns false. So that'll be it for today. Thanks for watching. Soon to come will be a similar video for dictionaries. Bye.